Hey guys, this lesson is lesson 4 of binary trees intermediate Python course. So this week we're gonna introduce you guys to OOP, which stands for Object Oriented Programming. So what is OOP? Well, here's an example. We're gonna be using the Harry Potter series. So what is each book part of? Well, they're all part of the major series, right? Like all 7 books. What does each book have? So, like, what are its attributes? Well, it has a name, it has a specific number of pages, a specific number of chapters, a release date, and what are some actions in each book? So, this could be some stuff from like the plot of the story or something like that. So, sort of like that, object oriented programming organizes codes into objects that contain both data and actions. So it models different types of real world things into code using its data, its attributes and its methods. So a car can have the properties color and brand and its actions to drive and stop. It's based off of the key concepts of encapsulation, inheritance, and polymorphism. Python supports OOP, but it's not fully OOP based. Java, on the other hand, is. So if you guys want to create programs that are fully OOP based, I'd recommend using Java for those. Here's an open-ended question. Give a few reasons why developers use object-oriented programming while building software. Well, a reason that developers usually do this is because object-oriented programming simplifies their code a lot. Instead of having to keep track of attributes, they can just attributes for each specific item using something like a list or something. They can just set up an object with different attributes and methods and just use those methods. So these are what they do. So we have a class and an object. The class is the blueprint, so it defines how objects behave. So basically classes look like this. For example, we have our class. Oh. And this will basically say, like, say for example, we'll do car. So color equals to car dot color. Sorry, my pen is bugging out really bad. But that's basically how classes work. It just says the car is going to have these attributes and these methods. And an object is the actual like object itself. So we could define an object like using that car example, like a Toyota Corolla that's red. Like the class says that its only attribute is its color, and we just made a Toyota Corolla that's red. An example, classes and objects. Based on this code, what would you expect as the output? So this is a car, and these are its attributes. So, and these are its methods. So init means initialize, and that's where we usually hold all the attributes. And then we hold methods inside of different functions. So this is the example here. So here, like in this area, this would be a class, and then this here would be an object. variables and methods. So instance variables store unique data for each object, and instance methods are functions inside of a class that allow objects to perform actions. So this is sort of like the difference between attributes and methods. The concept of self in Python. Self represents the current instance of the class. Each object maintains its own separate data, and self ensures that the correct object's attributes are used. Without self, Python wouldn't have the ability to differentiate between the different objects. So, like, here's an example. When using a method, we wouldn't use like greet or with the object's name. We would have to put self so that it can actually differentiate the objects. Now, this is the constructor for, so it's called when an object is created, and that's the initialize thing. Class attributes belong to the class itself. So, for example, here, species mammal, and this is shared by all of them. So it's not specific to any of them. Instance attributes, they're unique to each object. They're set using initialize. So here, this here is an example of initializing an attribute for each instance. Now, optional parameters, and these have some default values. So here is an example. So here it defines this stuff as brand unknown and color white, and then it changes them. This creates a default value, which it'll have. So here, it's going to be a red Ferrari, but here, we only know that it's a Bugatti, we don't know anything else, so it's just going to assume that the color is white. Here, it doesn't know the brand or the color, so it just assumes it's an unknown car that's white. These are reference variables with their scope. So there's method variables that are defined inside of a function or a method. The scope is local, it exists only within the function, and it cannot be accessed outside of the function or the object. A global variable, it is defined outside of any function. It's outside of all functions, and its scope is global. It's accessible throughout the program wherever you need it. You have to use it carefully to avoid naming conflicts within things. Instance variable. So this is those initialized variables that we were talking about, the attributes, and these are per object, and you access them via this function where it depends on the variable name. Here's an open-ended question. Differentiate between method variables and global variables. Right? So here we can go back here. So when would you use a method variable and when would you use a global variable? Well, method variables would be used in situations where you need a specific thing that's specific to only the function. And global variables is when you need something that can be accessed throughout the entire program. If they share the same name inside of a class, then there will be some naming errors within the program. Here's clean code versus spaghetti code. So clean code is well organized and uses proper structuring. Spaghetti code is unstructured, tightly coupled, and hard to follow. It leads bugs that are harder to catch, performance issues, and tangled logic. Clean code, low coupling between classes, easy to read and debug, and efficient and maintainable. Here's a practice question. What do class attributes define? A. Which syntax to use for a certain scenario. B. shared properties across all objects in a class, and C, parameters to use when defining objects. And D, variables to assign values in your code. So, class attributes define, so we can actually go back to, so here are the different attributes. So we have a constructor, a class attribute, and an instance attribute. And the class attribute means that all instances share the same value unless overridden, which is exactly what this one is. Shared properties across all objects in a class. Practice question, another one. What is unstructured, inefficient, and unorganized code called? I think we just went over this one. This is spaghetti code, right? As shown in the previous one. Yeah. So spaghetti code, it's hard to follow and in general inefficient. What would print dog species plus dog name if species is mammal and name is Python? Well, it would just print this out, right? Because first off, C++ isn't involved anywhere. And dog name has to come second, so this one doesn't. So since these two don't work, and species isn't the name, the species name is actually mammal. Sorry, my pen's bugging out really bad. But this doesn't work either, meaning that D is our only answer. How are instance variables created? A, by using the constructor initialize. B, by running print instance variable. C, by using only self. And D, by using swapping logic with a placeholder variable. Now, it's actually this one and this one. Because this will just print if you've already made one, and D is incorrect. In Python, what is the purpose of self? Well, it's out of these, it's not to show the user's coding software, the IDE. It's not to represent the current instance of a class. It's not to represent the current instance of a class, or to represent the current instance in a method variable, meaning that the answer is C. And that's all for this lesson. Thank you guys, and I hope I see you in the next one.